This is a good example on one-dimensional motion. Let's read it. Remember, physics is nothing but math word problems, so you have to read the problem carefully. An employee sneaks out of a car out of the parking lot by rolling it at a constant speed, 1 meter per second. Identify the information given to you. So this is initial velocity is 1 meter per second. And once the car hits the street, he steps on the gas and accelerates at 4.2 meter per second square. So this here is the second piece of information given to you, which is acceleration. A equals 4.2 meter per second square. Here's the question. How fast is the car moving after accelerating for 5 seconds? So T is given 5 seconds. And what's the velocity at the same time in mile per hour? That's a unit conversion. Now, it's always a good idea to start with some kind of a drawing just to give you an idea. Here's a car and travels for a distance. Let's assume this is the gate for the parking lot. So for this distance here, travels at a constant speed of 1 meter per second. Then once the car gets to here, he steps on the gas and it travels for 5 seconds. We need to know the final velocity here. Now the first equation that comes to mind is this equation here. The final equals the initial plus acceleration times time. Let's write it down here. This is an equation that you have to commit to memory. The final equals the initial plus acceleration times time. The initial, you might think it starts here. The initial, but since it's a constant speed, it remains at 1 meter per second all the way up to here. So this would equal to 1 meter per second square plus the acceleration 4.2 times 5 seconds, t. And you can always bring a calculator if you need to. And the calculator, 4.2 times 5 plus initial velocity equals 22. So the answer here is 22, and the units would be meter per second. Now the later part is miles per second square. I like to think of this as a table. I draw a table. Now the first part here, we have 22 meter per second. Obviously, you need to get rid of the meters and keep miles. So to get rid of the meters, you have to write them somewhere down here. We know that 1,609 meters equal to 1 mile. Now, how do I know this? I get it out of a table, conversion table. We still have seconds here, but we need hours. So to get rid of seconds, we have to write seconds here. So 1 minute, 1 minute is 60 seconds, and this would help the seconds to cancel with this. But we still have minutes. We need hours. So we write minutes up here to cancel out with this. 60 minutes equal 1 hour. Now notice the minutes here cancel with the minutes here. The seconds here would cancel with the seconds here. The meter here would cancel with the meter here. What we're left here is mile per hour. And a bunch of numbers that we have to multiply. So let's bring back the calculator, clear it, and we have 22 times 60 times another 60 divided by 1609. 1609, and that's 49.2. So your final answer here is 49.2 miles per hour. Let's go back to the second part. How far has the car traveled in this time? Now let's go back to the equation. How far is distance after 5 seconds? From here to here, traveled 5 seconds. T equals 5, and we need to know the distance. Let's go back to the equation here. Distance is expressed in this equation. Now we're assuming that once it hits the street, the initial distance is 0. That's our reference point. Initial velocity is given, times time, plus 1/2 acceleration is given, times time squared. So this is the equation we're going after. X is distance, initial distance is 0, plus initial velocity is 1 meter per second times 5 seconds, plus 1/2 times the acceleration, which is 4.2 times 5 seconds squared. Let's bring back the calculator. Okay. Let's start from here. You have a 0 plus 1 times 5 is 5 plus open parentheses 0.5 times 4.2 times 5 squared, which is 25, times 25, close parentheses, and this equals, and remember, what's the units for this? We have 57.5 meters. 57.5 meters. And that should conclude this problem.